In this illustration, we'll study the minimum required force to slide a body in a spring system. Here we are given two blocks of masses m1 and m2 connected by a non-deformed light spring, which is resting on a rough ground as shown in figure. If a friction coefficient on ground is mu, we are required to find the minimum constant force F to be applied on m2 so that m1 starts sliding. Here, as the system is placed on a rough surface, we can say m1 will slide if the spring force, which we can write as kx if x is the elongation in a spring, is greater than or equals to mu m1g. If the kinetic friction is less, then it will slide at equality, otherwise it will be greater. Now in this situation, F should be such that it should displace m2 maximum up to the distance x. If it will be displaced by a distance x, the spring force kx will displace mass m1. So here we can write by work energy theorem, assuming m2 is displaced by x. Here we can write initial kinetic energy of system would be 0 plus external force in displacing m2 by x will be doing a work fx minus the friction acting on it will be doing a work mu m2g multiplied by x minus the spring will absorb energy half kx square, and this should also be 0 because we are required to find the minimum force, so it should be at least displaced by x so that m1 will start sliding. And here 1x gets cancelled out and this kx we can write as mu m1g. So the value of force we are getting is mu m2g plus half mu m1g. So the value would be mu g multiplied by m2 plus m1 by 2. That will be the answer for this problem.